everyone. I'm Sonam Yadav, Assistant Professor, Biyani Group of Colleges. Today, the topic we are going to study is scintillation counter. So, we should know what is scintillation. Scintillation is also called a flashlight. So, mainly the scintillation counter is used to detect the nuclear particles through this photo multiplier tube. So, before going on that one, first we will study about scintillation. So, scintillation is as I already told is scintillation we can say is a flashlight. So, nuclear particles interact with some materials on this phosphor tube. From there they will produce a spark, and after going to photocathode we can detect which material is about to collected. So, from starting, this photomultiplier tube is made because only a single particle cannot be detected, or we can say a single flashlight of that particle cannot be counted. So, for that Rutherford and Rigner in 1908 also tried, but they failed. So, finally in 1947 Marshall and Coltman in USA and Kalman in Germany introduce a device that is photomultiplier, and this device is used for detecting the counting scintillations for different particles, like for alpha particles and protons. So, for the detection of alpha particle and proton, cesium iodide and zinc sulfide materials are used in this photocathode multiplier, and for beta particles naphthalene and anthracene are used. So, what is the working and what is the principle of this scintillation counter? So, here we have a tube, this we can say is scintillator. So, it is generally made up of phosphor, we can say phosphor is in this scintillator, and it is connected with a photo tube, this photocathode and denoted by C. So, these are some diodes. Mainly these diodes are made up of silver or magnesium. So, D1, D2, D3 up to so on. These are used to collect the particles emitted. So, from here, like since incident particle comes through this, so here a flash will produce. So, through this flash some of the particles get emitted, and these emitted particles, what these emitted particles produce is photon. So, photons are collected here. So, from here this is photocathode. So, photons will come here, and through here they will go to this diode D1. So, let us assume when these particles or these photons comes to diode D1, their intensity is 100 volt. So, after reaching these diodes, they will go to diode D2 with high intensity. So, here we can say that maybe the potential will increase up to 200 volt. So, up to so on, when from here they will get reflected and comes to diode D3. So, their intensity will be maximum, or we can say it is up to 300 volt and so on. So, after here we can collect the emitted electrons or emitted photons, and we can verify what is the nature of these particles. Maybe these can be alpha particle, maybe these can be beta particles. So, here and also we can detect the voltage pulse rate, and the voltage pulse rate depends upon the energy. So, here how much of the photons will be deflected or reflected is based upon the energy of that particles, that incoming particle, or we can say that incident particle coming to this photocathode. So, all this is the working and the principle of scintillation counter. This is photocathode and this is scintillator. So, the number of electrons emitted by the cathode, this cathode, the number of electrons emitted by this cathode is given as neta, E, alpha, Np and E. So, where neta is what? Neta is the fraction of the photons falling on this photocathode. How much number of photons are falling on this photocathode or is denoted by neta E, and Np is number of photons emitted by this phosphor, the scintillation. This is phosphor. And E is the energy of incident particle, the particle coming towards scintillator. So, this one is the number of electrons emitted by this cathode. So, what will be the number of electrons received by anode? That one is given as beta, Ne, alpha, Np and E, and where P raised to power n, where P is electrons emitted due to 1 electron. If 1 electron is incidenting on this photocathode, how much of the particles are received by anode? So, from this what we observe is voltage pulse height. So, voltage pulse height, what is the formula of voltage pulse height? Is V is equals to Q by C, where Q is charge carried by n electrons, and simply Q also can be given as Ne and C. So, we can put the value of n here, that is beta Ne alpha Npe P raised to power n by C. So, this is voltage pulse height. So, from all this we can say that the voltage pulse, the height of voltage pulse is directly proportional to the energy of the incident particle. So, there are some advantages of scintillation counter. The first one is scintillation counter has high efficiency of detection. Second, it also has high resolving power, and the height of voltage pulse is always directly proportional to energy of the incident particle, and the efficiency of gamma rays, it is very efficient for the detection of gamma rays or for the detection of energy of gamma rays. Thanks for watching this video. Please like and share this video and subscribe our channel Guru KPO.